So, hello friend, good evening to all of you. So now I will start second lecture of analytical chemistry. So in this lectures I will uh, remind you of my last lectures. So in last lecture I have discussed the column chromatography about the how to isolate the component from the mixtures and all those things, and I draw the pictures this column chromatography. Hopefully you understood easily, and now I will discuss the second parts of this instrumental techniques, this thermoanalysis. So I will discuss thermoanalysis. Inside this I will discuss TGA, DTA, DSC. So now we will start the thermoanalysis. So if you are not subscribe my channel, so please subscribe the channel and like, also share with your friends, and so that, and also you click the bell icon so that you can get the easily notifications when I upload new videos. So okay, now I will start. So what is thermoanalysis? Thermoanalysis means, if you see the terms thermoanalysis. Thermo is basically related to the temperatures. Thermoanalysis. Related to temperature. Related to temperatures. Okay. So inside this I will discuss first TGA, thermogrammetric analysis, second DTA, and third is DSC. These are are very important to this thermoanalysis, and in examples, in CSIR exams there are several questions exams have been asked. So it is very important. CSIR or other GATE exams or other entrance like MSc entrance exams. So I will start now. First, thermogrammetric analysis. So what is thermogrammetric analysis? So it is something, means grammetric means, if you see this term, grammetric means some related to mass, how to, or you can say weight, how depends weight with respect to temperatures. So in this technique, the sample we run at control rate, means temperature rate you should keep in control condition under nitrogen, carbon dioxide, helium, argon, like in these atmosphere we run the samples. So heat, when I heat the sample, at control rate, under the condition of like air, atmosphere, nitrogen, carbon dioxide or helium, like that, or argon. So these are the atmospheric conditions which you have to run this TGA technique. So what is the principle? So principle is, through this technique, weight change by increase the temperature. Point number 1. And if you understand this thing through by taking examples, like I took the examples of silver nitrate. So if we see this silver nitrate plot versus weight change versus temperature. So if we see the plot, will come like this. This is the temperature. Here is increasing order of temperature. If you see here, this is the horizontal line. Here your Ag3 weight does not change, remain constant. With respect to temperature. But if you see here, slightly this point, at this temperature melt or decompose your AgNO3, and you can see easily change in mass or change in weight of AgNO3. And if you see after these points, the melting process become constant, or there is no melting after these temperatures. Okay, so it means that so finally if we see, so what is the total change of weight with respect to temperature is known as the thermometric analysis. So basically here weight is decreases. So if you see this reaction, basically it decomposes to silver plus NO2 plus oxygen. So here weight is decreases. So there are two cases. Case first, when mass loss, then what will happen? Reactant, here one more condition here you have to add. Here the sample you should take in solid form. Okay, you should take sample solid form. Okay, so so reactant means your self mile should be solid and it decompose if increase the temperature, so form the product and some gas. So here if you see, form the product as well as gas. So here if you see, you compare these things, product and reactant, so you will see the loss of weight. So here loss of weight because formation of gas, some parts convert reactant into the gas. So here you will see the loss of mass or weight. You will see case second, mass gain. How to mass gain? You will get how mass gain. So mass gain basically if we see similarly this, if you react a gas with reactant solid, then form product. Here you will see the gain of mass. So there are two cases where you will see the gain of masses. Okay. So now here some notes ones. Note, you should remember. So without change in mass, we can't study or measure the TGA. I mean, without change in mass, we can't study by the TGA. TGA technique is not applicable when there is no change in mass of your sample happen. So it is necessary to change your mass, then you can easily differentiate or see the mass losses or gain. Second point, decomposition of sample depends on heating rate. Decomposition of sample depends on the heating rate. So, and third point, so what is the meaning of this point? Second means decomposition of sample. Decomposition of sample depends of your heating rate. So if your heating rate is controlled manner, then you can easily see the difference. If your heating rate is not controlled manner, then you will not see difference, means how much your mass or weight loss or gain happen. Okay, so meaningful points, these are the meaningful points. Third points, small weight of sample should be taken. That the small amounts, not you have to take bulk amount, you have to take a small amount of sample. Small amount of sample will be take small amount of sample will take. Okay, and also last point, size also matters. Particle size should be small or homogeneous. Particle size should be small or homogeneous, means your particle size is will be homogeneous, same size of your particle, or you can say it is it should be not be different size. Your particle size will be homogeneous, then you can easily perform your TGA experiment. Okay, so these are the points. So now I will go to the next technique, TGA, TDA. So next technique is TDA. Next technique, second technique, TGA. Now second technique, DTA, differential thermal analysis. DTA. So what is differential technique analysis? So It is based on temperature difference between test sample and inert reference sample. Under here also control rate and same condition of heating or cooling is recorded continuously as a function of time. So it is also basically you have to consider some regular rules, means temperature you have to run under control rate. So it is basically the temperature difference between test sample and inert reference sample. Under control condition or control rate. Okay, and this data record as a function of time, function of temperature or time. Okay, so conclusion: heat taken or released by chemical system determined. So here the conclusion is heat taken or released by chemical system is determined. Okay, so these are the important things you have to keep in your mind. Okay, if you see in diagram, it's take this diagram, draw this diagram, this. So here y-axis delta T and x-axis T or time. Okay, so if your test sample is constant and increase, the difference temperature change and then constant and then decrease curve like this, then what it indicates, here is your test sample, this peak comes through exothermic, because here you are giving some what I can say, here you have took two samples, like one is test sample and one is a inert reference sample. If you have two samples, like one this and second like this, this is first test sample and this is reference inert reference sample. Okay, so if we increase temperature both in continuous manner, okay, at these points here your temperature is same, but your test sample is showing some melting, but this inert reference sample is going increasing. So what is what is the difference between test sample and inert reference sample through temperature difference? Then you have to calculate these things, you have to determine these things. So what is the difference between test and inert sample? So you will get this peaks. This is the melting means endothermic reaction. Endothermic reaction means your sample is here melting and not rising up, but your reference sample is going up. So here is, if you see, here is melting, but your reference sample going increasing. Okay, so you have to maintain both temperature. So you have to provide energy so that can both are goes in same way. So here, that's why at the endothermic reaction is happened. But when will this peak come? So this peaks, exothermic peaks, means your reference inert reference sample is going down and your test sample going up. So some energy is released. Here if you see, here this is your test sample, and this is inert, this one is inert sample. So if you clearly see the difference of delta T here, so here is your test sample, here is your reference sample. So here some energy is released. So this is the exothermic process. Okay, so here these are the things. So this exothermic process is basically when the test sample increase temperature through crystallization, when it form as a crystal, and reference in lower temperature. Reference sample is in lower temperatures. Okay, reference sample is in lower temperature. So here for exothermic, delta T should be negative. Okay, sorry, positive. Delta T should be positive. and for endothermic, this is endotherm. Here delta T should be negative. Okay, so here basically your reference sample temperature going up, and here is your going down. That's why we need to provide some energy so that both are go in similar way, are rising up in a same level. Okay, and last point in this TDA, it affects through size and shape of sample and furnace holder as well as heating rate. So it affects size, shape of sample and furnace means heating rate. What is your heating rate? Okay, if you have any doubt, you can ask into the below comment section. I will again try to reply you if you have any doubt. So last in this thermoanalysis, discuss DSC, differential scanning calorimetry, like DSC. So in this thermoanalysis, this is the last points I will discuss DSC. Okay, so it is basically the difference in amount of heat required to increase the temperature of sample, and reference is measured as a function of temperature, and also both sample and reference maintained nearly the same temperature. So it is basically the difference amount of difference in the amount of heat required to increase the temperature of a function of a sample, and a reference is measured as a function of temperature, and also both sample and reference are maintained at nearly the same temperature. This is the definition about this DSC. First you read, then you will understood. So if we see also this through the figure, So if we draw plots energy, this energy versus temperature, so here the graph like go straight line, but this is not actual like that. So here if your sample is going like this, then if the energy increase of your sample, then melting will happen. So peak will comes like this. Okay, so here is same endothermic process will happen. Okay, so here and after again this constant, then again it become crystallize. So like this peak will come. So this is for crystallization, exothermics. So this is the actual graph of this DSC, and I am not a specialist in these fields, so if you have any doubt, so I will try to explain you if you will asked related this analytical chemistry, I will explain you. Okay, so this is all about thermoanalysis, and next layer I will discuss the spectroscopy term technique. Okay, so okay, bye bye, thank you, good night.